at the periodic table introduction. We're moving into a new topic, but the funny thing is you have to know the previous topic, atomic structure, to understand periodic table. We'll talk about more than a second. So what are we doing? We're doing periodic table, okay, intro. Alrighty, no problem. So the very first thing, the father of the periodic table is considered to be Mendeleev. Okay, so I'm going to write his name down someplace. Okay, Mendeleev. Okay, and he arranged the periodic table, guys, by the atomic mass. Alrighty, all right, atomic mass, and he also used the chemical reactivity of the elements, right, to place them within specific groups. Okay, so what did Mendeleev use? The mass and chemical reactivity to place them in specific places on the periodic table. And the nice thing about it is that elements that weren't discovered yet, he predicted where they should be. And later on, years afterwards, when they found that element, his predictions proved true. For example, I think with silicon, for example. So, you know, very brilliant guy. Okay, moving on. Next guy that you need to know is Henry Moseley. Okay, and he came up with the fact, right, that you should arrange the periodic table by atomic number. Now we know from atomic structure, right, atomic number is essentially the number of protons. Okay, so that's how the periodic table is arranged today, by the number of protons. Very, very important. Okay, and that was known as the modern, okay, periodic law. All right. So if they ask you what's the modern periodic law, just say, you know, it's the law that states that the periodic table should be arranged by the number of protons. And Mendeleev, called the father of the periodic table, he arranged it by mass and chemical reactivity. There were some other scientists that contributed to the periodic table also, but as always, sometimes they don't get much accolades, no problem. So guys, we're gonna move on over here. I hope you can see my periodic table up here. Now, if you can't see that properly, no problem. Grab your own reference table, go to the periodic table, just follow along with my notation, all right? So you have to know the groups, people, okay? So first group is group 1, all righty? Now, before we give the name of group 1, what is a group, right? A group or family, right? Okay, so make a note, a group or family is a vertical column on the periodic table. So you look from top to bottom right here, that's group 1. Top to bottom right here, that's group 2. This is groups 3 through 12, 13, 14, 15, 16, 17, 18, and so on. Vertically from top to bottom, okay? Alrighty. So group 1 is called Alkali Metals. Alrighty. Now, the groups or families, right, have something in common. Just like how your family, you tend to have the same last name. Groups in the okay, in the same vertical column, they tend to have the same number of valence electrons, especially for the representative elements like group 1, group 2, and these guys on this side right here. Sometimes the transition metals could be a little strange. Alrighty, but definitely very important to know they have the same number of valence electrons. And the reason why they're in a particular group or family is that when you have the same number of valence electrons, you tend to behave the same way in terms of how you treat those valence electrons. Sometimes you lose them the same way, not the same amount. Sometimes you gain them the same way. Sometimes you share them the same way, okay? So once again, they have similar, I'll write it down here, similar chemical reactivity, okay, if you're in the same group. So if they ask you, for example, which element would tend to behave like another element, automatically think, okay, I'm looking for the same group, I'm looking for the same number of valence electrons. Very important. Okay, so group 1 is called Alkali Metals, all right? Now, alkali refers to basic. Now, I asked my students When I took living environment, could you remember the pH scale and so on? If you can't remember, it's no big deal. Goes from 0 to 14, 7 neutral, above 7 is considered basic, right? So when you react metals in group 1 with water, for example, they form hydroxides. Now, if you don't know the term hydroxides, don't stress, but it makes a basic solution. You put a red litmus paper in, it'll turn the red litmus paper blue, okay? So no problem, bam, done. So that's group 1. Group 2, alrighty, are called alkali or alkaline earth metals. Okay, alkaline earth metals. You gotta remember these names, folks. All right. Now, alkaline earth metals, okay, have 2 valence electrons, right? 2 V's. The guys in group 1, they have only 1 valence electron, 1 VE. Okay, so we gotta know that. Very important. Also, they form basic solutions, just like the guys in group 1. But the group 1 guys tend to be much more reactive. Okay, so make a note that alkali metals tend to be very reactive. We'll talk about why later. We're just giving the names of the groups right now. So alkali metals, very reactive, okay, and form basic solutions. Group 2 metals are also reactive, but not as much as group 1, right? So they're all just, I'm gonna just put reactive. They're reactive, okay, not as much as group 1, but you know, decent reactivity, okay? And they also form basic solutions. Alrighty, all right, so we're moving on. So we got group 1, group 2. Now we're gonna move on to groups 3 through 12. I didn't bother drawing all the columns, people, so you know, don't write me. Just for the sake of space. All right, so groups 3, can you guys see? Right here, groups 3 to 12 are called transition metals. Transition metals, okay? What about them? They're pretty unique in that some of them, right, because of the way their electrons are arranged. Now, I'm not going to talk a lot about D sublevels and so on, so I'll leave that out. But the way their electrons are arranged, right, they're able to form, okay, colored compounds. That's a unique thing about them. They tend to form, a lot of them do, form colored compounds. All right? Okay. So that's like almost like a trivia that you have to know about them. They also have half-filled D sublevels, but like I said, I'm not going to stress that too much. They used to ask that back in the day on the readings, but not anymore. Okay, moving on. Now we're going to skip 13, 14, 15, 16 guys. Are they important? Yes, they are. But do they really ask you about their properties and so on? Not really, no. So, you know, just know that, you know, that they're, you know, what we focus on a lot, though, what, you know, quiz and test on what is important to know is group 17 and 18, right? So group 17, so we'll fit it in here. Group 17, 17 are called, very important, halogens or halides. Okay? Now guys, the guys in group 17 have 7 VE, 7 valence electrons. So they're also very reactive. Now here's the deal, folks. Here's the deal. In atomic structure, we did talk about stable octet, right? Trying to achieve a stable octet. So these guys in group 17 only need 1 more to gain to get to a stable octet. So think of them as looking around, scavenging around, looking for 1 more electron. The guys in group 1, okay, have to release only 1 electron to have a full valence shell. Okay, most of them are stable octet, except hydrogen, right? So they're looking around, scavenging, okay, to get to give someone their electron. So what happens is, when we can learn in bonding, right, that the guys in group 1 and the guys in group 17 is like a match made in heaven, right? So one guy wants to release, give off his valence electron, another guy in group 17 wants to gain. So you can think of it as that, okay? So So they help each other out, which we'll talk about more in bonding. So that is a key in relation to their reactivity, right? Okay, okay, no problem. So we're gonna move on to group 18. I'll use a different color. Okay, group. Hopefully you guys can see this red. I think you could. Group 18. Now group 18 are called noble gases. All right? Now noble gases, folks, have what? They have full valence shells. Okay, very, very important. Many of the guys in the periodic table are trying to get to a noble gas configuration, people. Okay, they want that full valence shell, just like the guys in group 18. Okay, so no problem. So based on the fact that they have a full valence shell, they're very, okay, extremely unreactive. Okay, I think of it as they've reached a place of peace when they have the full valence shell. They're happy, they're very, very stable and very unreactive. Okay, no problem. So maybe there's a few there, one or two maybe that have an oxidation number that have some very limited reactivity, but for the most part, noble gases are very, very unreactive. Now guys, I'm gonna say one more thing before I close off. Over here. Okay, you see this guy right here, this Bohr model? It's essential, right guys, before we jump into any kind of trends, before we jump into any kind of definitions and so on, that you remember and understand the structure of the atom, people. It's like, you know, it's absolutely crucial. So let me look over here if I can find some guys. So let's go to our memory banks. All right, let's look at lithium. Alrighty. So lithium, we did this before, right? Lithium has 3 protons, because protons give atoms their identity, right? So if you got 3 protons, where are you gonna put them? You put them inside of the nucleus, yes? Okay, right in the center right there. Remember, this is the nucleus and not the scale, no problem. Now, it just so happens, right, the mass number of lithium, right, is around 7, okay? So it means that if that's 3 protons, it must have what? 4 neutrons. So 3 plus 4 is 7. Remember, protons and neutrons give the mass of the atom, okay? So 1, 2, 3, 4. Now, why am I stressing this, people? Because when we get into ionization energy, electronegativity, and all the other trends, you have to understand the structure of the atom, folks. If you don't understand the structure of the atom, all the stuff that we talk about and how these different trends are affected, it's not going to make any sense, all right? So protons and neutrons in the nucleus. And remember, you have electrons in the energy levels. The first energy level can hold a max of 2 electrons, alrighty? And the second one can hold 8, remember, based on the 2n squared rule, right? But it only has 3 electrons, 3 protons when it's neutral. So put 2 in the first, 1 in the second, bam, you're good to go. But the location of the electrons, very, very important. Location of protons, very important. Knowing that they have shells, very important. Knowing that the outermost shell is called the valence shell, and knowing that the electrons inside that valence shell are called valence electrons, also very important. So we're gonna move on to trends later, guys. But for right now, this is our introduction to the periodic table. Get to know your group names, properties of those groups, okay? Why they behave that way, and so on, people. All right, take care.